The objective of this assignment is to make a multi-node Hadoop cluster and run HDFS commands on it in a Linux environment. We also implemented MapReduce using word count as an example, which displays the frequency of each word in the file.
Now we will create the master virtual machine. For that, we will open the VirtualBox and we will go on the new option. We will name the virtual machine as master. We will select the type, which is Linux, and the version, which will be Ubuntu. And as we are using, so first we'll set up the hardware. We will assign it 1024 MB RAM and one processor core. And now as we are using the installer image, we will select the installer image we downloaded from our download section and select the file and finish the process. Now we will open the virtual machine we just created. We'll wait for it to load. As we can see, the virtual machine has been created.
Now in the master VM we just created, we will create a user named SD user. Through this SD user we will run Hadoop. So for this we will log into the virtual machine. We will now run the add user command to create the user. We will assign it a password. Now we can skip filling these details. And now the user has been created. We will add the user to the sudo group using the sudo user mod -ag command. Now we will install nano and vim because we will need text editors in the future to edit the configuration files. Now we will log in as the SD user. Now we are in the SD user. We will update to have all the latest packages. So it is better to update once we have created the new user. Now we will install the net plans, net tools. This will be useful because we will have to check the IP address of the virtual machines, and we use ifconfig command to do it, which is part of this net plans, net tools. And now we will go to the hosts and we will rename this virtual machine as master. And now we will reboot to let the name change set in. Now we will install Java in the virtual machine. For that we will just run the command sudo apt install openjdk 11 jdk. We are installing Java because Java is a very important component of our assignment. It is a prerequisite when we are working with Hadoop, So it is a no-brainer to install Java. We will wait for this to install. See now the installation has finished, so we will just check through the command java hyphen hyphen version, and we see that Java has been installed properly in our system. Now we will download Hadoop. Hadoop is the soul of our assignment. So for that we will first log into the master VM, and then we will use the wget command to download Hadoop from the archive. So we have shown the link here in the top left corner, and we are downloading Hadoop version 3.2.3. So this star.g.z file is an extension for a zip file. So from the website we will get a zip file which we will later unzip. We should make sure that the version number should be correct. If you want to download some other version like 3.3 or above, so you can just change the version. The archive has all the files there. So now we will wait for this to finish. As we can see now the file has been downloaded. Now we will unzip the file. For that we will use the tar-xvzf command. Now the file has been extracted. Now we can see Hadoop has been installed in our system successfully.
The master and slave virtual machines to communicate with each other. We will need to set up a host-only adapter between them. A host-only adapter is a setting in VirtualBox which allows the VMs to privately communicate between themselves and the host machine. So we will go to the in the tools section and properties and network in the host only networks, and we will create a new VBox a host only network named VBox network as is already done. We will change the adapter settings. We will set an IP address and we will enable the DHCP server and set the server address. You will click on apply, and now we will add this adapter to the master virtual machine. So in the settings in the network tab, we will change adapter 1 to host only adapter and set it to VBox net 1, and set the adapter 2 to the NAT network, to NAT mode, sorry. And we will click on OK to apply these settings. Now from the host Ubuntu machine, we will SSH into the master node VM. So we will first check if we are able to communicate through the ping command, and after that we run the SSH HD user, that is the name of the master node VM and its IP, and now we are in the master node VM. Now we will configure the Hadoop environment. So for that we will first configure the -rc file. So we will open it in Vim and I will paste the following configuration changes at the end of the file. We will change the Java version to 11 and the Hadoop version to 3.2.3, which is the version installed in our virtual machines. And then we will save the settings and use source command to apply these settings. For convenience, we have already made a folder which contains the files that need configuration files that need to be changed in Hadoop. So we have named that folder master config and we will copy that folder to the Hadoop folder. This will override the configuration files and it will save time. So we will just have a look at these files. First we will see the code site XML file. Next we will see the HDFS site file. Here we set the replication factor as 2. Next we will see the workers file. These are the 3 slaves, worker 1, 2 and 3. Now we will see the yarn site file. Now we will see the Hadoop env.sh file. Here we will have to change the Java home thing to 11. That is the Java version in our system. You can do it accordingly to the Java system you have. And now we will copy this folder containing the final configuration files to the Hadoop folder. Now if we change the directory to the etc/Hadoop, which contains all the configuration files, we can see that the R configuration files have been copied here and overwritten the existing files. So now we will be able to run Hadoop.
As each time we have to access the slave nodes from the master node VM, we will have to SSH into them. So instead of writing their IP each time, as we have made the IPs static of all the master node and the slave nodes, we can just we can just map the IP address to the host name. So for that, we will we will open the host file in the etc library. So we will use the sudo vim and open the file, and here we will write the IP addresses and the host name. So first we will write the IP address of the master node VM, which is the 192.168.56.101, and now we will do the same for the slave nodes. So for slave 1, slave 2 and slave 3.
Now we will create our slave VM. So for that in VirtualBox we will go to the master VM we have and right click on it and click on the option. We will name the machine as slave 1 and make it a linked clone and set the MAC address policy and start the slave machine. Now we will log into the slave machine. We see that as it is a clone, it already has root files. So we will just have to change its host name first here to slave 1 instead of master. So we will change it to slave 1. Now we will apply that change. We can see the change has been applied. And now we will open the net plan here in the virtual machine and we will change it to static IP. So in addresses, we will set it to 102, which is the IP of slave 1, which will be the IP of the slave 1 virtual machine, and we will apply this net plan. We will SSH into the slave 1 virtual machine now. And now we are in the machine. We will make a directory named slave config files and copy uh, the config files we have made to this folder. So we'll do that using the scp command, which is the command used for Linux in Linux to copy files around. So this we are doing from the host Ubuntu machine to slave 1 virtual machine. And now again SSH into the slave 1 virtual machine and we will see that we have the files, we would have the files in slave config folder. Now we will copy these files from slave config folder to the Hadoop folder that contains the configuration files. Now we can move to that folder and we can just look at the files and make a few changes. Now to set up slave 2, we will again clone the master virtual machine from VirtualBox. We will open the slave 2 virtual machine. We will log into it and we will again make the same changes that we made in the slave 1 virtual machine. First, we will change the host name to slave and we will apply this change. As we can see, the change has been applied. Now we will change the net plan to set it as a static IP. So now here we will set the IP to 103 because 101 is the master, 102 is slave 1. We will generate the new net plan and apply it. Now from the master, sorry, not the master, the host Ubuntu machine, we will SSH into slave 2. We will copy the configuration files we had in the host machine to this. First, we'll delete the master configuration files because that were for the master, and for the slave configuration, we will make a new. And now we will copy the worker configuration files to the slave 2 virtual machine. Now we'll copy these configuration files to the Hadoop configuration files to override them. And now we can go to the Hadoop configuration files and see that they have been changed. Ah, yes, we have to change Java home here also again. Now slave 2 has been set up.
Now we will set up the slave node 3's VM. So again we will clone the master node VM as we did for slave 1 and slave 2. We will name it as slave 3, make it a link clone and set the MAC address policy. We will click on finish and start the slave 3 nodes VM. So we will wait for it to load. Now we will log into the VM. We will change the host name. We will change it to slave 3. Now we will apply that change. As we can see, the change has been applied. Now we will make the IP static by again going into the net plan and changing the address to 192.168.56.104. 101 is master, 102 is slave 1, and 103 is slave 2. And we will generate the net plan, and we will apply the net plan. And now we will SSH into this new virtual machine of slave node 3 we have created from the Ubuntu host machine. Now we are in the slave node 3 virtual machine, and as we can see we have the Hadoop files, but we will remove the master configuration files folder and make a new slave config file folder. And from the host machine, now we will copy the prerequisite config files for the slave nodes we had already made to slave node 3 VM. And now we will again SSH into the slave node 3 VM and copy the slave config files to the Hadoop, which will override the Hadoop configuration files in this virtual machine as well. We will change the Java home in the Hadoop env.sh file to 11 because we have 11. Save it, and now we have finally set up all the master node VMs and the slave node VMs, so we can move to running Hadoop. Every time we will run Hadoop, we will have to SSH into the slave node VMs from the master node VMs. So in the in the master node VM, we will generate a SSH key and we will copy that key to all the slave nodes. Through that, we will get a passwordless access into the slave node VMs when we SSH into them each time. So let us implement this. We have opened all the four VMs, the master VM and all the three slave node VMs. So for generating the SSH key, we will run the command ssh-keygen, and this will generate the SSH key. We have generated the SSH key and we will copy it to first the master VM itself using the command ssh-copy-id and a space hduser@master. So hduser is the username, and @master we have mapped the IP address of the master VM to master. And now we will do the same with slave node ssh-copy-id hduser@slave1. This will copy the SSH key to slave 1, and now we can SSH into slave 1 without the entering the password. We do the same for slave 2 and slave 3. And now we have copied the SSH key to all the slave nodes. If we want to SSH into slave 1 VM, we can do that without entering the password. We can SSH into slave 2 also without entering the password. And we can also enter slave 3 without entering the password. This shows that the SSH key has been copied correctly, and now we can finally move to running Hadoop. Now after setting the Hadoop environment, we can finally run Hadoop. So before that we will run the HDFS name node format command to format the all the nodes and apply all the configurations we have made for Hadoop to run smoothly. So now we'll run the start all.sh command to start Hadoop. So finally we have reached one goal of our assignment, which was to run the HDFS file system using Hadoop. So it will take some time. Now the system is running. We can verify it using the JPS command. We can run JPS in all the slave nodes to verify that they are also connected and are running. We can go to the local host port 9870 to check that the Hadoop is running. There we can view the number of live nodes, number of decommissioned nodes, the file system, and many other utilities. So we will type in the URL bar 192.168.56.101 port 9870. So here you can see that the commission nodes are three nodes, no, none of them are decommissioned. Slave 1, slave 2, slave 3 are visible, and we can see the file system. At present there are no directories because we haven't created any, so let us now do that. We will create a directory using the command HDFS DFS hyphen mkdir, and the directory name we are naming the directory temp. And now we will create a file to insert in the directory. So it is a text file. Now we will add the file in the directory using the HDFS DFS hyphen put command, and at the end file name which is sample.txt here, and after the file name the directory name, so sample.txt space hyphen temp. So after reloading we can see the directory has been created and the file has been created. We can see replication in slave 3 and slave 2, and the contents of the files are also visible. Now we will stop the process. To implement MapReduce, we will need a jar file which will be created from the Java file. So for that, we will create a new project in IntelliJ to work on this. So we will name the project MapReduce, and we will set the language as Java and the build system as Maven and create the project. So this is a new project created. So we will delete this file because we already have the files with us. So we will make a class. We'll create three files, one for mapper, one for reducer, and one for the runner. In this XML file, we will add the dependencies we will need. So we will copy them and paste them in the XML file. Now we will copy our mapper code. Runner code. We will import all the packages that are seen here. So now we have imported all the packages we need to run the mapper file, to run the runner file. Now we'll copy the code of the mapper file and paste it there in the class we created. Again, we will import all the packages we need. And we'll paste the code here. For reducer now and reducer, we will again import the packages. Now our IntelliJ process is ready and we can run it. And now we have gotten the jar file which we'll need to run map word count. So the jar file was made in the Ubuntu host machine. So we will copy it into the master virtual machine. So using SCP, we can copy the jar file to the master node VM, I should say. And now we will SSH into the master node VM. As we can see, we have the jar file here. So we will start Hadoop. As Hadoop was already running, so we see some errors. So we will first stop Hadoop. Now we can again start Hadoop. Now that it has started cleanly, we can now implement MapReduce using the word count example. So for that, we'll create a text file which will serve as the input. So we will just add some random text into it. Now we will add this file into a directory in the HDFS file system, which is in the name temp. And now we will run the word count example using the jar file. So the command is Hadoop jar, name of the jar file, the class name of word count, and we will specify the input here as temp slash input.txt in our case and the output directory. We should note that we cannot use the output directory again. So if we have used output again, we have to name it output one or something else. And here we see the process. It is running. We can also see the percentage of map and reduce. We saw 0% and 0% in both there. So we will wait for it to complete. So now as we can see, the job has been completed, and we will navigate to the Hadoop and see the file system. In the file system, we see that there is a new directory with a file success, and here we see the word count. So Hadoop is twice, hello is twice, and MapReduce has come three times as we saw in the file. So this was our implementation of the word count example using MapReduce.